All right, so we are going to look at a new and improved method for solving not just nice, neat, whole number factoring quadratics, but even a method that will work nicely for even the not so nice quadratics. In order to do that, we need to establish a definition for something that we call perfect square trinomials. So in this first topic video, we're going to talk about what a perfect square trinomial is. So take a look at this picture I have of 3 examples of perfect square trinomials. Now I'm showing it right now as a basically what we would have with algebra tiles if we were working with algebra tiles. I want us to talk about the factored form, so I'll write factored form. And I also want to talk about the standard form and what that looks like for perfect square trinomials. I'm going to put that up here too. Perfect square trinomials. So we know what a square is. A trinomial just means a equation that has 3 terms in it. So that will make sense to you in a moment, I think, as we get a little bit further. So let's think about what this first perfect square trinomial would be looking at the factored form. First, let's assume that all of these are positive. So looking at the dimensions, this would be x plus 3 by x plus 3. So not surprisingly, a perfect square trinomial starts out with a perfect square of algebra tiles. So that would be x plus 3, times x plus 3. And actually, if we want to write that in a simplified form, we could actually just write that as x plus 3 squared, because remember, squared just means that we take something and multiply it by itself. So right now we have x plus 3 times itself, x plus 3. So we could simply write this as x plus 3 squared. Okay, let's look at this next one. Same idea. X plus 1, 2, 3, 4 by x plus 1, 2, 3, 4. So I could write that as x plus 4 times x plus 4, or I could simply write it as x plus 4 squared. And then lastly, we have x plus 1, 2, 3, 4, 5 by x plus 1, 2, 3, 4, 5. Again, a perfect square in shape, and we would write that as x plus 5 times x plus 5, or just x plus 5 squared. So in factored form, we have x plus 3 squared, x plus 4 squared, x plus 5 squared. Now keep in mind that x plus 5 squared is not like x squared plus 25. You don't distribute a square. That's not what a square is. Square means you take something and multiply by itself. So again, x plus 5 squared is the quantity x plus 5 times the quantity x plus 5. And if we were to multiply that out, that would be a whole lot more complex than just x squared plus 25. And in fact, let's figure out what that would be. So for this last one, since I just started working on it, x times x would give me x squared. X times 5 would give me 5x, and then 5 times x would also give me 5x, so that would give me my 1, 2, 3, 4, 5 plus 1, 2, 3, 4, 5. 5 and 5, that's 10 x's. And then 5 times 5 is 25 ones. Or we could just count that up in here and get 1, 2, 3, 4, 5 by 5. That's 25 ones. Again, so that's the standard form. For this middle one, I would have 1 x squared. I would have 4 and 4, so 8 x's. And then a 4 by 4 section of ones, which gives me 16. So 4 and 4 gives me 8 x's, and 4 by 4 in this area gives me 16 ones. And then lastly, we have an x squared, and we have 2 groups of 3 x's. That gives me 6 x's. And then we have a little square here, 3 by 3. That gives me 9 ones. So these are 3 examples of perfect square trinomials. How do we recognize a perfect square trinomial if we just have it written down? Let's use a different color here for a second. So let's say I just were to give you x squared plus 16x plus 64. And I were to tell you, or I were to ask you, is this a perfect square trinomial or not? How would we know? So let's look at our examples. This is in standard form, so let's look at our 3 examples of standard form perfect square trinomials. Actually, here you should see why these are called trinomials, by the way. Remember I said that means 3 terms. Each of these has 1, 2, 3, 1, 2, 3, 1, 2, 3 terms. The first one, we have see kind of a relationship between the number 6 and the number 9. So 6 is basically 3 plus 3. We get that by 1, 2, 3 plus 1, 2, 3, right? So this is 3 plus 3 x's. And 3 by 3 ones. So 9 is 3 times 3. So we have 3 plus 3 x's and 3 times 3 ones, which should make sense from our picture why that would be. So this is 2 times 3, and this is 3 squared. That would be in a different way of saying it. We see that same pattern happening here. We have 4 and 4, so this is 4 plus 4 x's, and then we have 4 by 4 ones. So we have 4 plus 4 gives us the number of x's, 4 times 4 gives us the number of ones. And here as well we have 5 plus 5 is the number of x's, and 5 by 5, 5 times 5, gives us the number of ones. So anytime we have a perfect square trinomial, we'll see this relationship between the x's and the ones, where there's like we think about it in terms of like the dimensions, an x plus 3 times x plus 3. So whatever that extra number, this is 2 times that number, and this is that number times itself, or that number squared. So here it would be 2 times 3 is 6, 3 times 3 is 9. Here it would be 2 times 4 is 8, 4 times 4 is 16. Here it would be 2 times 5 is 10, 5 times 5, 5 squared is 25. So we ask, is this example down here, is that a perfect square trinomial? And in order to know that, we have to decide if it fits our pattern. Could I turn this into a nice, perfect square? If it's going to be true, we have to have a number that n plus n will give me this number, and n times n will give me the number of ones. So take a second, think about that. Is there a number that will do that? Well, if you thought of the number 8, you were headed in the right direction, because the number 8, if I say 8 plus 8, that gives me the number of x's, and if I say 8 times 8, that gives me the number of ones. And if you think about that in terms of a square, I don't have to even draw it all out, but I'd have x squared up here, and then I'd have 8 x's here and 8 x's there. That would give me my 16x, and then I would have an 8 by 8 section of ones, which would give me my 64 ones. So is this a perfect square trinomial? Yes, it is. It fits our pattern. All right, that's it for this first video. Make sure you write all of that down, and make sure you have an idea of what a perfect square trinomial is. And in the next topic video, we're going to see how that might help us in solving quadratic equations.